Welcome to today's video on standing waves. Standing waves are a fascinating phenomenon that occurs when two waves of the same frequency travel in opposite directions and interfere with each other. Let's start by understanding regular traveling waves. A traveling wave moves from one location to another, transferring energy as it goes. Here's a simple example of a wave traveling from left to right. Now, let's discuss standing waves. A standing wave, unlike a traveling wave, doesn't appear to move. Instead, it seems to stay in place with fixed points that don't move at all called nodes and points of maximum movement called antinodes. Standing waves occur when two identical waves traveling in opposite directions interfere with each other. This most commonly happens when a wave is reflected back along its original path, like a wave on a string fixed at both ends. Let's see how the interference of two traveling waves creates a standing wave. We'll start with one wave traveling to the right. Now, let's add another identical wave traveling to the left. When we add these two waves together, the result is our standing wave. Now, let's see a practical example of standing waves on a string fixed at both ends, like a guitar string. When the string is plucked, waves travel in both directions and reflect at the fixed ends. The resulting interference creates standing waves. The simplest standing wave pattern that can form is called the fundamental frequency or first harmonic, with only one antinode in the middle. The second harmonic has two antinodes and a node in the middle. The third harmonic has three antinodes and two nodes between them. Let's animate these standing waves to see how they actually move. Here's the fundamental frequency in motion. Notice how the entire string moves up and down together, with the maximum displacement at the center. Here's the second harmonic. Notice the node in the middle that doesn't move at all, while the two halves of the string move in opposite directions. And finally, the third harmonic. Two nodes divide the string into three segments, with adjacent segments moving in opposite directions. Standing waves are not just theoretical concepts. They have many real-life applications. Musical instruments like guitars, violins, and pianos all use standing waves to produce sound. The different harmonics give each instrument its unique timbre or sound quality. Standing waves also occur in electromagnetic waves, like in microwave ovens where they're used to heat food. Engineers need to consider standing waves when designing structures like bridges to prevent resonance that could lead to collapse. To summarize, standing waves occur when two identical waves traveling in opposite directions interfere with each other. They have stationary nodes where there's no movement and antinodes where the movement is maximum. Standing waves play a crucial role in physics and engineering, from musical instruments to building design, and understanding them helps us better comprehend wave behavior in general. Thanks for watching our video on standing waves.